Okay, so number 2. Oh, and all the questions are there, so that's good. Let R and S in the figure above be defined as the following. R is the region in the first and second quadrants bounded by the graphs 3 minus x squared. That's a negative x squared. That means reflected down and shifted 3 units up. So this graph is that function right there. 2 to the x is an exponential growth, doubling each time. And S is the region bounded in the first quadrant where the blah, 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 everything. So you see the S is shaded. Find the area of S. Okay, so if I'm finding the area of S, am I integrating area? No. When you integrate area, you get what? Volume. So what do you integrate in order to get area? Or simply y values. Okay? And what are y values? They're just top minus bottom. That's the y distance. Okay, so we need to come up with some sense of top minus bottom to get this thing going. Okay, this is a number 2, so you would have a calculator. Let me get my calculator set up. Okay, so my calculator set up, just real quick. Just logged on. Home 2, menu C, OK. OK. I'm going to do this with you right before you take the AP exam. You all are going to go up there. It's in the arena. You grab a calculator. You can grab 2 in case one of them glitches and freezes up and you don't want to lose time. I would suggest to have 2 just in case that does happen. Because it has glitched. 1 year it did. On the TI-84s it glitched for like 3 or 4 minutes and it just kept working and they couldn't turn off the 84. But did it glitch for this? It didn't. Oh well, the other people didn't have it. But we already had these, so it didn't affect us and our students. But please make sure you have 2 because sometimes these even glitch. Okay, so it's home 2, menu C. So home 2, menu C, OK, OK. 1, 1. And control out of page, get a graphing calculator by pressing 2. And now go back. And you're ready to go. Okay, so let's look at the problem. We want to find the area of S. Already, what can you tell me that I'm probably going to be looking for? I'm going to what? Where they intersect. So right here, I want to see what is this point to how many decimals? 6. To see where they intersect. Okay? So we're going to set both of them equal to 0. We're going to do a solve feature, and we'll see what we get. Okay? Here we go. So 3 minus x squared, 2 to the x. Let's see what we get. So menu 3, 1, 2 minus x squared is equal to what? Or did I do that wrong? It's 3 minus x squared is equal to 2 to the x, right? And then we're going to do comma x. And we have it at negative 1.6, and then the other one is at 1. Obviously, we want which one? The 1. So we're going to go here, and this is going to be 1. If you want to know what the y value is, just plug it into any one of these, and obviously the y value is going to be 2. So far, so good? Okay. All right. So it looks like to me the easier way to do this, well, let me ask you first. Is it dx or dy? Dx, I think. Okay. So I would do dx from 0 all the way to 1, and then dx from 1 all the way to what? Oh, we got to figure that out. We got to figure out when is this graph equal to 0? Root 3. So this is going to be at root 3, 0. That's this point. And then you just have at x is equal to 0. So you're gonna set 2 integrals. Here we go. From 0 to 1, and then we're gonna add it with the integral that's what? From 1 to root 3. So let me do it like this, not to confuse you. Are we good, guys? Okay, so now we said there were dx's. Now I just got to figure out what's the top minus bottom. What's the top on the first one? 2x minus the bottom. And then it's going to be plus what's, oh my gosh, what's the top over here? 3 minus x squared. And what's the bottom? 0. So let's put parentheses minus 0. I know I'm over parenthesizing that piece, but it's all about this negative and making sure that I distribute it on that second one if and where needed. You with me? Okay. So all I have to do is just put this into my calculator. And I'm going to do that right now, but if you can like take a photo shot of that in your head real quick and just help me out, because here we go. Or I could do that too. Alright, so it'll be the integral from 0 to 1 of 2 to the power of x minus 0. We don't need it, but we'll write it. And then dx. Oh, control enter. And then go up, copy, and I would write 1.442695. And now I'm going to take the integral from 1 to root 3. Here we go. The integral, and I'm going to show you something really cool at the end with programs that you'll be able to do this to check your work on a problem that looks like this, but I want to teach you how to use the program. I didn't want you to become dependent on it, but here at the very end I will show you how to do it. And yes, you could put minus the 0 on this, just like we over parenthesized from before. I don't know if that's a word, but I'm using it. Alright, so this one is 0.797435. So on the calculator, I just probably control C this, or just copy it, and I would say this plus this, and I would write 2.240. There's my area. Are we good? Check this out. Watch what I'm about to show you, okay? And yes, I will transfer these to your calculator. You just gotta know how to use it. And I'll probably do that through videos so that you can watch the videos and then you can use it if you so choose to. Check this out. I'm gonna go to, whoops. I'm going to transfer these programs that we built for CalCAPS. And I'm not going to transfer them all. I'm only going to transfer the ones that you would need to use or could use if you chose to. But they look something like this. Okay, here we go. They look, can you control up for me real quick? Now go down to the first empty page. Keep going, keep going, keep going, keep going. Right, okay, right there. Press enter. Now, you're going to press VARS, calculus. Showing you how to do this on the video. Pressing it again. And what are y'all looking for? Slope, area, or volume? Area. So you'd put A. Is the area given? You're going to say no, but it is given for us on calculator applications test. Guys, how many functions did we use on that other one? Was it bounded by 2 or 3? 3. Let's go back to it. It was bounded by 3 because you had a top left, you had a top right, and you had a middle, or sorry, a common bottom of 0. Okay? So let's go to this and go through it. So we're going to press 3. And you tell me, what did we do this in respect to? X or Y? X. What was the top left function, if you can remember? 2 to the x. Nice memory, good, good. So 2 to the x. What was the top right function? 3 minus x squared. Okay? This is only to help ease your stress whenever you were testing. What's the bottom same function? 0. And notice, it's prompting y equals, because you put dx. Had you put dy, it would prompt you as x equals right now. Okay? Are any of these trigonometric? No. If they were and you put yes, it would find the intersections for you. You wouldn't have to manually put it in, solve feature this and solve feature that, and it would spit those ones out. So we're going to put no. Guys, it found the intersections anyway. So we have a negative 1.637 and we have a 1. This is in scientific notation. For you, we would undo that and you would just see it as normal to 6 decimal places, okay? What's the lower bound that you would put here? 0. What's the middle bound x value that you would put here? 1. And what's the upper bound? That one you would actually have to solve or just write it down. What is it? Root 3. So root 3, 3. And then make sure you close your parentheses on roots. You just have to. And there's your area. 2.240. Cool? That's one way to use it. And it even does volumes with trigonometric as well. Okay, so can you use it on the AP exam? Heck yeah, you can use it. You don't have to clear your calculator. You can take whatever you want. And does it kind of make sure that you did get the correct answer? And if not, go back, change some work. Something went wrong. Get enough practice with these programs though, just to make sure that you are in fact doing it correctly. Alright, so let's go back to our problems. Where were we at? Was it this one? No, it was that one. Okay, so we found the area. Good job. Alright, so find the volume of the solid generated when R is rotated about the horizontal line, Y is equal to 1. Let's recap. We know that this was root 3, 0. Huh? Oh, did I say 1? Okay, my bad. Y is equal to negative 1. We're going to rotate this about. Y is equal to negative 1. Thanks for that. Okay, and then we said this one was what? 1, 2? Perfect. Are we good? Alright, so let's set this up. We want volume, so we have to integrate area. Okay? dx or dy? Dx, because they're vertical. You're rotating it about a vertical representation, so it'll be dx. Now here's the question. Is it disk method, which is this, or is it washer method? Okay, which is not that. Which is this, which will constant multiple rule out. Either way, we're going to constant multiple rule that thing out. Okay, so it is washer. If it was disk, then the bottom piece would be touching that axis of revolution the entire time, and there would be no void. But guys, there's so much void right here. It's a black hole, if you will. Okay, we don't want that if we're doing disk method. So this is going to be a washer method because of that void. So we'll say pi big R squared minus little r squared. Here we go. This is huge, okay? Where it could jump you from 2 over the weekend that some of you might have gotten to like a 7, just like this with this video, okay? As far as the rotation is concerned, always start from the axis of revolution and go out to the outermost rim of that area. Now look at it. Top minus bottom. That's it. What's the top?
1 plus 2 to the x.
Just 2 to the x. What's the bottom? Negative 1. So top minus the bottom is what you will get. That some people would be actually confused by doing it the way he did it. If you struggle with this, still do top minus bottom and you'll get it correct. Okay? Alright, so top minus bottom, yes, it is 2 to the x plus 1. Now, from the same axis of revolution to the innermost function, what's the top? 0. What's the bottom? Negative 1, and you're going to subtract top minus bottom. So all it is 1 squared. Okay? So with the calculator, we're going to quickly go to this, and we're really just integrating 2 to the x plus 1 squared minus 1, because 1 squared is still 1. And whatever it is that we get, that is our volume. So let me go ahead and put that in there right now before I start changing the screen. So pi the integral times the integral. I'll go ahead and switch now. Okay, so pi times the integral from, what was it? Do y'all remember?
0 to 1.
Oh, we didn't even write that down. From 0 to
1.
Well, here's the thing. The big R squared minus little r squared. We're going to have to do two pieces here, aren't we? Because if we have to do two pieces with the area, you're going to have to do two pieces with the volume as well. So all we're doing right now is this area here. So we would have to do plus another one. Pi big R squared, right? You with me? This is a really good problem. But anyway, so it'll be top minus the bottom of 0 squared, because that's big R, minus the top of the other one, which is what? Oh, hold on, wait a minute.
Why wouldn't it be minus 1? Like minus a negative 1?
2x the top minus bottom. Yeah, you're right. So hold on. Let me slow down just a little bit. Went a little bit too fast, and my picture's all kind of whack right now. So before we start the second one, we are looking to find this right here, rotating about y is equal to -1. So let's go from the axis of revolution to the outermost function, and the top function there is 3 minus x squared. Top minus the bottom, which is correct, which is a -1 squared. Are we good? Minus little r squared. Little r is going to go from axis of revolution to the inner one. What's that one going to be? It's going to be 0 minus -1. Okay? So all this would simplify out, and you could say 3 minus x squared plus 1 squared minus 1 if you wanted to simplify it out. And whatever you get from this and from this is a really good problem anyway. So as far as I'm going to be able to show you with the program as far as how fast it goes to verify. Whatever that you get from that, you're going to get your answer. Okay, so here we go. What are the bounds for this first one right here? 0 to 1. What are the bounds for this one? 1 to √3. Okay, so 0 to 1. I'm going to keep it like this because I can't see it otherwise. 2 to the x, and then I'll switch it over. Plus 1 quantity squared minus 1, and then dx. And then we get an answer. Okay, and then I'll do the other one, pi times the integral from 1 to √3, and it's going to be parentheses 3 minus x squared plus 1, so you could put 4 minus x squared if you wanted to, 4 minus x squared quantity squared minus 1 dx, and you get these answers right here. Okay, let me go to the calculator. You get 15.86, so let's copy that for 6 decimals. Let's copy this for 6 decimals, and my volume is 373. So 24,373. Okay. Let's try to do it with the calculator now. And you can watch this through video next time. Just remember that number for me, please. Alright, so let's go back over here. And here we go. We'll go to calculus. We'll press it until the screen pops up. And what do I press in? Volume. So put V. Notice the letters that I put there. If you put capital V, it won't work. It's case sensitive. Is volume given? No. 2 or 3? 3. What's the axis of revolution? X or Y equals something?
Y.
Okay, so, but be careful. You're just going to put Y, okay? Now it'll ask you, what is it? -1. Okay? What's the top left function? 2 to the x. What's the top right function? 3 minus x squared. And what's the bottom same function? 0. Are any of them trigonometric? No. Okay. And when it does that trigonometric, it's only because it has to find the sinusoidal intersections. Otherwise, it's still going to give you intersections that occur. Okay? So here we go. What's my lower bound? 0. What's my middle bound? 1. What is my upper bound? Root 3. And make sure to close these roots, otherwise it will error out. And there you go. Again, this is in scientific notation, so that e to the 1, or e1, is like saying times 10 to the power of 1. So you'd move the decimal over, and sure enough, this would become 24.373.
In what case would the volume be given?
Oh, that's what I'm saying. For calcaps, sometimes the volume is given, and we're trying to find, like, what is the constant multiple number that comes out in front that would make that volume possible? What is the vertical stretch or stuff like that? You see what I'm saying? So we built programs so it'll find it by when you saw a picture in it. You know what I mean? You won't ever see that. Oh, you won't ever see that. That's for calcaps. Okay, C, the region R is the base of a solid. For the solid each, this is a really good problem, thank you. For this solid, I've said that like 4 or 5 times now. Each cross section is perpendicular to the x-axis. So that means perpendicular to the x-axis is parallel to the y. So all these cross sections are like this. And the things that are popping out are isosceles right triangles with one of the legs across the base of the solid. So they're isosceles, right? We know that it looks like this, x, x, x root 2 of some sort, okay? And we're saying that, bless you, one of these isosceles pieces is the piece that's resting on the graph's base. Okay? So it's like popping out of the screen like this, if you will. Okay? And then obviously the bigger piece would pop out even more. So there's a bunch of these triangles, and if you can imagine, they're just popping out and they're all glued together. Weird shape. Okay? Alright, so what we're going to do is write but not evaluate. I love these kind of problems. An integral expression that gives the volume of the solid. Can someone tell me, if we're going to integrate area, and it is dx because it's perpendicular to the x, otherwise parallel to the y, what's the area formula for this triangle that you see? 1/2 x squared. Okay? So base times height. Base times height, they're always at perpendiculars. Times 2, 1/2 I mean. 1/2 times base times height. This is the area. This equation is what's going to go here. This constant multiple rule of 1/2 out. So all we need to come up with is something that represents x. And guess what? We're going to do this 2 times because of this weird shape. We're going to do it for the one that's from 1 to root 3. And we're also going to do it for the one that's what? 0 to 1. This is a hefty problem. This is, I'm not going to say it again. All right, so 0 to 1, 1/2. Now, we just have to figure out what is the length of that x. What is this length right here? And guess what? It's only top minus bottom. So to be, for the first one, top is this, minus the bottom. Be careful, this one's not -1, right? This one's just the basis area. Okay? And then the top minus bottom over here would be the top minus the bottom. You can over parenthesize if you need to. And that's it, guys. And then, of course, you'd put an addition in between, and you'd be done. On a scale from 1 to 10, this is a 10 when it comes to area and volumes. And this included everything. Cross-sectionals, the programs, the dividing it into 2 different, you know what I mean? The only thing that this didn't have, that sometimes it would have, is that what horizontal line would cut this area perfectly in half, where there'd be equal area on top and bottom. That's the only thing, but we're not going to do that. Okay.
I'm confused, like, on how you get the area equation, like, just in general for, like, triangle.
Because a triangle is 1/2 times base times height. And it said specifically that this was isosceles. So from special right triangles, remember a 45, 45, 90 is x, x root 2? They're saying that one of these isosceles legs is resting on here. So that's how you know this area right here is going to be base times height divided by 2, which is 1/2 x squared. Any other questions? How'd y'all like the programs? You gonna use them? I mean, I think they're helpful.
Would you recommend using those like after
mean, that's one point to everything. And if you show the answer with no work, chances are they're going to think that you cheated, which is not what we want. You got to show the work and justification. Just use it to check. Cool.